learning that is new today is the notation that we're going to show our answers in. You guys should know how to solve inequalities. When do you flip the sign in an inequality? Yeah, when you divide or multiply by a negative, right? That's when you flip the sign, so that's probably going to be the most complicated part. You know how to solve equations with fractions, so that shouldn't make it too challenging, or decimals, that shouldn't make it too challenging. So again, like I said, the only thing that's going to be new today is the notation that we're going to show our answers in. Okay, you ready? Too bad. So, what we're going to be looking at today is something that's called interval notation. Okay? There's two different notations that are out there in the world. There's something that's called set notation, which is used often in pre-calculus, and interval notation, which is also used a lot. Or in college math classes, lots of times they'll make you use interval or set notation depending on what the professor is asking you to do. So we've done set notation with our solution sets. So that's just the fancy squiggles, fancy braces around the number. So for your quiz yesterday, if you got x equals 3, you should have said the set of 3, which is set notation. Well, now when we have inequalities, I don't just have one single number as a solution, right? I have a multiple amount of solutions because I'm thinking about it as an inequality. So let's quickly think about what this is telling me about. If I had, let's just say x is greater than 2. What are some numbers in that solution set? 3. 4, 5, 6, 7, 8, 9, 10. Is 2.1? Sure. 2.000000001? Sure. Is 2 a solution? No, 2 is not a solution because it doesn't have that equals 2. Okay, well, instead of just having 2, all they're doing is turning this into an A, and they're just putting the A first and the X second. This says the same thing. X has to be greater than some number A. So this is what set notation looks like for intervals. You define the variable, which is why this X is here. So the first thing you do is define the variable. In this case, our variable is most likely going to be X. That line, or that bar, stands for such that and then this gives you your rule. So, X such that A is less than X, or I'd like to say X is greater than A. That's the way that I think about it. Okay? All right. So that's what set notation looks like for inequalities. In your past life, last year, you would just say X is greater than 2. Done. That's my answer. Well, in set notation, it would be X such that X is greater than 2. That's all we're adding. So if you're asked for set notation, that's what it's going to look like. Now let's talk about what that looks like as an interval notation. But before we do that, let's focus on the graph before we get there. What does this graph look like on a number line? If I had some number A, and X needs to be larger than A. Do you guys remember putting open and closed dots? Would this be an open or a closed dot? This will be an open dot. Okay, don't put this on your paper, just watch, because this is not going to be how we graph anymore. Which way would my arrow go? If I want X to be larger than A, it would go to the right. So it would be all numbers greater than A, not including A. Okay? So in advanced algebra, we're going to get fancy with our work. And instead of an open closed dot, so here we had open dots. Okay, so instead of an open dot, we're going to use a parenthesis. Instead of a closed dot, I want to jot this down in your notes. So a closed dot, we're going to use a bracket. And it will face the direction of whatever way the arrow goes. So these will be for greater thans. I would flip them if I was pointing my arrow to the left. Okay, so in this case, we have an open dot Now we're going to think about it as a parenthesis. And then my arrow goes to the right. That's my way of shading. Okay. So, what's my starting point in this case? If that was 2, or if that was 3, I would be starting at 2 and getting larger or smaller? Larger. And technically, this arrow is going until what number? Infinity, because it's never stopping, right? So when we set up our interval notation, this is going to look like an ordered pair, but it's not an ordered pair. It's interval notation. I have an open parenthesis at A, which, keeping in mind, A is going to end up being some number that we will solve for when we get to our inequality. And it's going to go to infinity. And I'm going to put a parenthesis around infinity, because would I ever be able to include infinity? No, infinity is not a stopping number. It goes on and on and on and on and on and on and on forever. Okay, so whenever you have an infinity, that's always going to be a parenthesis. Okay, so this interval notion is telling me that my set is going from A to infinity, not including A, and of course not including infinity. Interval notation. So set notation, interval notation, graph. All right, so now let's change the way that it goes. Oops, come back. Did I miss one? I feel like I keep hitting oops. I guess I went to the combined one. That's all right. Okay, so next one, we have the variable x such that x is in between A and B. So this is a compound inequality. So again, that interval notation is telling us that our variable x is in the set such that it is in between A and B. Do I have equal signs down here? No. Nope. So we're still not going closed dot. Before we do the interval notation, let's look at the graph. There's my number line. Here's point A. Here's point B. Now, if we were in Algebra 2, we would do an open dot at both A and B and just shade in between, because x is in between A and B. But now we're stepping up our game and turning our open dot into a set of parentheses. So I'm going to put parenthesis, parenthesis, shade in between. Okay, so then this kind of helps you to see what my interval notation is going to look like. My interval notation is going to say, well, we're going to start at A, but we're not going to include A. We're going to stop at B, but not include B. Okay. So far, so good? What would change if we turn this into equals to? Yeah, this would become a bracket, and these would become brackets. All right, we'll get there. Let's do all the open ones first. All right, last open interval. Now we're going to go less than. So here we have the set of x such that x is less than b. So again, in previous life, you would just say x is less than 2. We could easily graph that. Open dot at 2, arrow goes to the left. But now we're going to make it fancy and be able to write it in set notation and be able to write it in interval notation and then make the graph with the appropriate marking. So I'm going to do the graph first. So we have our number line. Here's our b. Now is my graph going less than or greater than in this case? Less than. So I'm going to turn my parentheses so it's facing the less than direction and shade my arrow to the left. All right, now let's think about where this arrow is going to. Is this arrow going to infinity? Well, infinity is that direction. It's going to negative infinity. There is such a thing. So this is going to negative infinity, and you always work left to right. So we're starting at negative infinity. Again, your infinities will never have brackets around them because you can never close it off. And we are going to B and stopping there, not including B. Okay? All right, so now let's just do the same thing but close them up. So back to the first one. Oops, never mind, I forgot this one. X is a real number. What do you think that would look like?
Infinity, fine.
Yeah, there it is. So remember when we got our set notations for our equations, all real numbers or no solutions? Well, what happens if you end up with an inequality that is all real numbers? So here we have the set of X such that X is a real number. So that means it can be any single real number. And Kevin had it right. How do we show all real numbers? Well, that goes from negative infinity to positive infinity. So now when you get a solution of all real numbers, we can think about that as negative infinity to positive infinity. Okay, so this would have worked for our equations that had all real numbers as solutions, but these all don't work for equations. It only works for inequalities. All right, what does that look like as a graph? Put the phone away, Justin. And it's just the whole entire number line. So you just make a very thick number line. Okay, set notation, intervaltation. Here we go. Here goes our equals to. So I was going to do the same top three and just add an equals to bar. So we have the set of X such that A is less than or equal to X. What's that going to look like as our interval notation? First, are we going to positive infinity or negative infinity? Positive infinity, good. My starting point is at A. Because it is including A, I'm going to use a bracket. And remember, infinity always will have a parenthesis. So we're going from A to positive infinity. What does that look like as a graph? At A, bracket, shade to the right. What about the second one we did, where A is less than or equal to X, less than or equal to B? That's just going to change for our interval notation. Oh, hold on, I didn't do both of them. What would this look like? Let's do all the three different variations. Is A included in this case? No. Is B included? Yes. So this would be a parenthesis A, bracket B. Do I have to do the graph, or you guys know what the graph would look like? I'll just do it quick in case you want it. So it would be A, parenthesis, B, bracket, shade in between. I'm sure these are right below it, but I'm just going to go with it anyways. If we switched the inequalities or the equal sign so that it was less than or equal to A, but only less than B, then what would it look like? Bracket A, B, parenthesis. Good. And if they were both equals to, it would be what? Bracket, bracket. Are we getting the point? What would the last one be for if we were less than or equal to B? It would be negative infinity to bracket B. So X such that X is less than or equal to B. So then it would be negative infinity B bracket. Okay? So that's the only thing we're adding is the notation. Do we think we have a good feel on the notation? Okay, so now let's do the easy stuff. Let's actually do the solving part.
Yes.
Through all that. All right. Look how simple that looks. X minus 7 is less than negative 12. Probably already have an answer. What do we got? That ain't 7 to both sides. It's okay. It's the morning, Andrew. All right. In our past life, we would be done. But we need to show our answer in, let's practice both sets. Okay. On the quiz or the test, I will specify which set to do. Your textbook, I think they put all of their answers in interval notation. But let's just practice both of them. What would this look like in set notation? So x such that. And then you can literally just write it like this. X less than negative 5. You don't have to worry about putting the negative 5 first. That's set notation. So remember, we had set notation with our equations because we would just do fancy thing 3, fancy brace. All right, so that's your set notation. What would it look like in interval notation? Yeah, parentheses, negative infinity. Negative 5 would have a parentheses because we don't have the equals to. What would it look like as a graph? Yeah, and I'm way okay with lazy graphs. Just put the one number on there. If you've got it between two numbers, then just put those two numbers that it's in between. And I'm okay with that as your graph. Okay, so set notation, the set of x such that x is less than negative 5. Interval notation says we're going from negative infinity to negative 5, not including it. And there would be our graph. Okay, all right, let's do another one. 14 plus 2m is less than or equal to 3m. First step would be to do what? Good. So then we get 14 less than or equal to m. For my own thought process, I like to always put the variable on the left-hand side. So I'm going to just flip that to m is greater than or equal to 14. It's the same thing. I'm just rewriting it differently. What would that look like in set notation? Set notation is probably the easiest because you just plop it in there. Yeah, good. M such that m is greater than or equal to 14. Would be set notation. Interval notation would be what? It would be a bracket, 14 to infinity. If you can't get to that right away, make your graph first. Sometimes that helps. Okay. If you start making a closed dot, be like, oh yeah, closed dot is a bracket. And then my arrow is going to the right. So what is that? Starting at 14, going to positive infinity. All right. So far, so good? Can we get these to be a little bit more challenging? That one's too easy. Let's find. Here we go. Let's do one. Then we have to flip the sign. Negative 4k is less than or equal to 32.
Divide negative 4.
Yeah, and then you got to make sure you remember to do what? Flip the sign when you divide by a negative. So we get k is greater than or equal to negative 8. Again, let's just practice both sets. K such that k is greater than or equal to negative 8 will be my set notation. What would be my interval notation?
Negative 8 or infinity.
Yep, what would be the sign at the negative 8 bracket? Good. This is the equals to, makes it a bracket. Bracket, shade to the right. Okay. All right, let's find some harder ones. Those are pretty easy. Ooh, there we go. You gotta love those fractions. Let's bring those into our life. All right, negative 2/3 times r minus 3 minus 1/2 is less than 1/2 times the quantity 5 minus r. What would I multiply everything by to get rid of the fractions? Why 6? At least it's the greatest common denominator. Remember, you always, least common denominator and greatest common denominator are always opposite of each other. Your least common denominator is always like the largest number. Your greatest is always the smallest number. It's confusing. All right, so let's multiply everything by 6. I could multiply everything by -6 right away to get rid of that negative sign. But if I did that, what would I have to remember to do? Flip the sign. So do you want to do that now, or do you want to do it later, or just see where it goes? Let's see where this goes. Okay, so what's 2/3 of 6?
2/3 of 6.
So do 6 times 2 divided by 3. 4. So that's going to be a -4 times r minus 3. Half of 6 is 3, less than another half of 6, which is 3, times 5 minus r. All right, let's keep going. Distribute property. -4r plus 12 minus 3 less than 15 minus 3r. Combine your like terms. -4r plus, is that 9? It's less than 15 minus 3r. All right, what would you guys do? That's what I would do, because I don't like negatives, especially with inequalities. So 9 less than 15 plus r, almost there. Subtract your 15 from 9, which gives you -6 is less than r. I like to rewrite it, my r on the left. Should be r is greater than -6. Okay, let's jump right to interval notation. That's pretty easy. What would that look like as an interval notation solution? Justin?
Parentheses, -6. Yeah, that.
Infinity, good. And if we graph it, -6, parentheses, shade to the right. Okay? Fractions are friends, they're not that scary. You just get rid of them right away. Okay, so let's go to compound inequalities. You guys remember your compound inequalities? Maybe. So here we have -2 is less than or equal to -3k, -1 is less than or equal to 5. So now I have two inequalities, which means I'm going to be left with an a and a b, so two different numbers, that x, or in this case k, is going to be in between. So if I ignored this part right here, how would you solve that inequality? What would be your two steps? Add 1 and then divide by -3, which means we would have to eventually flip the sign. If I ignored this side, what would be my steps? All right, so the steps are the same for both, right? So I can do each step to both sides.
So you add the 1 to both sides?
Yep, because it's the same no matter which inequality I start with. So just do it for both sides. So -2 plus 1 is -1, less than or equal to -3k, less than or equal to 6. What do we say the second step was going to be? Divide by a -3. Don't forget to flip that sign. 1/3 is greater than or equal to k, which is greater than or equal to -2. Okay. Because we are always working from left to right, which is smallest to largest, I'm going to rewrite this whole thing with my smaller number on the left and my larger number on the right, which means that I'm going to have to keep the sign closed to -2, which just flips it over, and open to 1/3. Okay, so if I needed to put that into set notation, I could easily just do k such that, bam, done. Beautiful. What would that look like in interval notation? Yeah, bracket, -2, 1/3, bracket. What would that look like as a graph? Just plop -2 on there, 1/3 on there, bracket, bracket, shade, in between. Okay, so the ands are pretty easy. You're just going to have your variable in between two numbers. It's always going to be smallest to largest. Now are you ready for the hardest part? The ORs. You guys remember the ORs? Yeah, do you remember what an OR graph looked like? Yeah, it goes in opposite directions. So our ands is the intersection of the two of them. Our ORs end up being unions of them. Maybe I don't even have, I guess maybe we don't get those today. Wouldn't you guys be lucky? Let me look. They might be coming up. Yeah, if they come up, next section. Section 5, we'll get to the ORs. All right, so you guys keep it easy. ORs are the fun ones.